We may have to relinquish the notion that changes of paradigm carry scientists closer and closer to the truth. In this episode of Philosophers Explained by me, Stephen Hicks, we turn to Thomas Kuhn's 1962 The Structure of Scientific Revolutions. Let's go to the text to see why we may need, when discussing science, to abandon notions of truth and progress. Structure of Scientific Revolutions, perhaps the most cited work in the social sciences and historiography in the past half century. As we go through the key excerpts from this relatively short book, less than 200 pages, we're going to start with the table of contents, flagging some of the key concepts that Kuhn will be stressing and explicating. So we have history, normal science, concept of paradigms, anomaly and anomalies, revolutions, changes in worldview or philosophical outlook, and then the concept of progress, and there will be some discussion of truth in there as well. But let's start with Kuhn as a historian of science, and what he's arguing initially is that we need to stop doing a top-down, abstract, philosophical, ahistorical understanding of science and start from the bottom up, or the ground up, so to speak, by looking at science as it has been practiced as history, and then perhaps drawing more general lessons from that fact. History, and the way the history of science has typically been done is after the fact, and the quotation picks up here. Inevitably, however, the aim of such books is persuasive and pedagogic. A concept of science drawn from them is no more likely to fit the enterprise that produced them than an image of national culture drawn from a tourist brochure or a language text. This essay aims to show that we have been misled by them in fundamental ways. So the way history has been done is we have a certain image of science, but it's an after-the-fact understanding of science. Often it is a tidied-up image of science. Sometimes it's history as written by the winners of various sorts of scientific debates. And so what Kuhn wants to do is see how science is actually done, mess, warts, and all, and then draw broader lessons from that. So those texts, for example, the wrong kind or the old kind, often seem to imply that the content of science is uniquely exemplified by the observations, laws, and theories described in their pages. And such texts typically have an image of science that looks like this. Scientific development becomes the piecemeal process by which these items have been added singly and in combination to the ever-growing stockpile that constitutes scientific technique and knowledge. So there is a cumulative process of kind of discrete facts, and then principles that are derived, and then the next generation of scientists adds some more facts and adds some more principles, and it is characterized then as a progressive enterprise. And that's what Kuhn wants to suggest and argue is wrong. What we have then found is, as we've tried to do the history of science that way, that it leads to all sorts of puzzles that can't be resolved and doesn't seem to fit the historical record very well. And so, as Kuhn points out here, historians of science have begun to ask new sorts of questions and to trace different and often less cumulative developmental lines for the sciences. Rather than seeking the permanent contributions of an older science to our present vantage, they attempt to display the historical integrity of that science in its own time. Now here we have permanent contributions, the idea that in some sense science is absolute or timeless or eternal, or that it comes up with universal things. That we are going to reject, and instead we are going to be what we call historicist. And historicism is a kind of relativism applied to doing history, where we see a historical time in its own lights. We don't apply the standards from another time to that particular time. So we relativize, rather, our concepts, our modes of understanding of any given time period. So we're going to display the historical integrity of that science in its own time. So rather than saying that there's some permanent truths or some timeless universal truths that we can measure earlier historical eras in science in terms of, we're going to abandon that and see each historical era as having its own, and the word he uses is integrity here, but here the idea is coherence or internal consistencies, and that's what we will be looking for. So these historical studies, that is to say the newer approaches to the history of science, suggest the possibility of a new image of science. So that is to say, we're going to, when we have a more general philosophical understanding of the nature of science, it will be a different one. So what are some of the elements of this new understanding of science? Well, first, there's an element of subjectivity, accident, and peculiarity at the basis of science. We're going to set aside the notion that the scientists, rather, somehow are objective, or that they are not weird and some eccentric or peculiar individuals who have their own uniqueness that shapes what they see, how they see, and so on. So, first, this suggestion. The particular conclusions he does arrive at are probably determined, and that's a very strong word, not influenced or having a part of, but determined by his prior experience in other fields, by the accidents of his investigation, and by his own individual makeup. So science is going to start in a accidental, individualistic, and be determined by the unique circumstances that a scientist find themselves in. So we start there with that suggestion. Then, as we are going to go along, the early developmental stages of most sciences have been characterized by continual competition between a number of distinct views of nature, each partially derived from and all roughly compatible with the dictates of scientific observation and method. So pausing there, in the early stages of a science, we might have a certain amount of data, even a certain amount of data that we all share or can point to, but nonetheless, our initial views of how to put that data together will be distinct and quite different. So there will be a number of competing hypotheses or proto-theories in early science. Now, Kuhn then draws a stronger conclusion. What differentiated these various schools was not one or another failure of method. That's to say, that it's not that some were pre-scientific, mixing in all kinds of weird, magical, weird, or unusual viewpoints or various kinds of subjectivity. He wants to say that all of them, as the quotation goes on, they were all scientific, although we're putting that in quotation marks. But what we shall come to call their incommensurable ways of seeing the world and of practicing science in it. And incommensurable is then to say that you cannot measure them against each other, and you cannot directly compare them against each other. That in order to understand, you need to kind of step outside of one and step into another. But then once you are inside this other one, you can't really compare it to the other one that you left earlier. So they are in different and distinct and not comparable ways of looking at the world. So that's a little retreat also at this stage from a kind of objectivity, that we are all observing the same data, that we're using the same methods, and we just have, say, temporarily put the jigsaw puzzle together in a different way. It's stronger than that. An apparently arbitrary element compounded of personal and historical accident is always a formative ingredient of the beliefs espoused by a given scientific community at a given time. So this arbitrariness that starts from the individual scientists, but then each community has its own arbitrary way that it has developed to some extent, and those cannot be expunged. It's always a formative ingredient in science. So again, another little retreat from the idea that somehow we are objective or grasping intrinsic truths. We have to say there's this other more subjective and arbitrary elements as well. Now, what then happens as a science begins to mature, right? It institutionalizes itself, and this is Kuhn's concept of a mature science. At least in the mature sciences, answers or full substitutes for answers to questions like these are firmly embedded in the educational initiation that prepares and licenses the student for professional practice. Because that education is both rigorous and rigid, these answers come to exert a deep hold on the scientific mind. So what then happens is once a given theory or paradigm, as we're going to come to call them, comes to be established, it shapes the educational institutions. New students who are coming in, of course, they will have their own individualities and peculiarities, but they, in effect, will be, I don't want to quite use the word indoctrinated yet, but they will be rigorously inculcated in that way of looking at the world. And students will not be able to challenge or question or think outside of the kind of education that is instilled in them by the educational authorities. Now, once we then turn to the practice of most scientists who are working in the established scientific theory, or paradigm as we'll come to call it, and working within established scientific institutions, what is the nature of their work? We often think of scientists as open-minded, as free thinkers, as challenging each other's in these ongoing debates and so forth, and as being open to new evidence and trying new ways of thinking about things. Kuhn says, no, that's not the way it works. As we go on to talk about normal science as it's mostly practiced, we shall want finally to describe that research as a strenuous and devoted attempt to force nature into the conceptual boxes supplied by professional education. So I've got my theory, and I try to squeeze or force nature to fit into my theory. And so we're reversing what is sometimes held to be the notion that there is nature or reality, and what we are doing is modifying and changing our theories to fit the way nature is. It's not that objectivist project, it is a more subjective project. The theory comes first, and we try to squeeze nature into the theory. So much so that we no longer are open-minded and even willing to consider fresh kinds of evidence and objections and criticisms and so forth. As Kuhn puts it here, normal science, for example, often suppresses fundamental novelties because they are necessarily subversive of its basic commitment. So something comes along that's new, that does not fit into the conceptual boxes that we have. Do we then say we need to restructure our conceptual boxes, or do we say this doesn't fit, I dislike this thing, and so therefore I'm going to suppress it? So there's a kind of closed-mindedness to the point even of perhaps censorship of things that don't fit the theory. The subjectively arrived at a theory that I have been taught and that I'm working within, that comes first. Now, sometimes we try to do this and we can't get away with it for various reasons. Sometimes a normal problem, one that ought to be solvable by known rules and procedures, resists the reiterated onslaught of the ablest members of the group within whose competence it falls. On other occasions, a piece of equipment designed and constructed for the purpose of normal research fails to perform in the anticipated manner, revealing an anomaly that cannot, despite repeated effort, be aligned with professional expectation. Sometimes we just can't do it. And after repeated attempts, we'll kind of recognize, okay, we do have a serious problem here. At this moment, then, we will enter into a revolutionary stage where science has to change fairly dramatically. And Kuhn gives us some historical examples from early modern science: Copernicus, Newton, Lavoisier, and Einstein. So Copernicus in astronomy, Newton in mathematics and basic physics, Lavoisier in chemistry, Einstein in physics again. Each of them necessitated the community's rejection of one time-honored scientific theory in favor of another incompatible with it. Each produced a consequent shift in the problems available for scientific scrutiny and in the standards by which the profession determined what should count as an admissible problem or as a legitimate problem solution. And the important point here is that this is not an evolution, it is a revolution. Everything gets turned around. Right? The methods, the content, the nature of the conceptual boxes, what counts as a problem, and then the scientific institutions, including the educational institutions, will be revolutionized. Right? And it is the new outlook is then incompatible strongly with the previous one, that concept of incommensurability. The new theory implies a change in the rules governing the prior practice of normal science. The new theory, however special its range of application, is seldom or never just an increment to what is already known. It is a revolution. Now, then Kuhn goes on to point out that we are doing history here, and that perhaps a better label for what we're doing is sociology or social psychology of scientists as they actually are functioning. But he does then want to say that there are some generalizations here that we are going to enter into philosophy and reach some conclusions that are philosophically. So we do the history, we do the sociology, we do the social psychology of real, actual scientists, and then the conclusions will be generalized to more abstract, logical, and epistemological principles. Now, that's an introductory survey in the first chapter of Kuhn's book. In chapter 2, he goes to the concept of normal science and how we get there. Normal science means research based firmly on one or more past scientific achievements that some particular scientific community acknowledges for a time as supplying the foundation for its further practice. So it's a community of people who are accepting some principles for a time. We're not making any absolutist or eternal claims anymore. And what we are going to do is based on those prior set of commitments. And then one mark of this is that there is a text written by a mature, great member of that particular scientific community that serves as the basis within which the community works. So some of the classics from the history of science that would count here: Aristotle's Physica, Ptolemy's Almagest, Newton's Principia and Optics, Franklin's Electricity, Lavoisier's Chemistry, Lyell's Geology, and so forth. Now, what makes these texts and these foundational commitments special? They were able to do so because they shared two essential characteristics. Their achievement was sufficiently unprecedented to attract an enduring group of adherents away from competing modes of scientific activity. Simultaneously, it was sufficiently open-ended to leave all sorts of problems for the redefined group of practitioners to resolve. And now Kuhn introduces his distinctive label for this concept. Achievements that share these two characteristics I shall henceforth refer to as paradigms, a term that relates closely to normal science. So we have a community of scientists organized around a founding text that defines what the methods are, what the problems are, and we are working within that tradition. And of course, we are training the next generation of students who will become mature scientists. How do we prepare the student for measurement, or for membership rather, in the particular scientific community? Because he there joins men who learned the basis of their field from the same concrete models, his subsequent practice will seldom evoke overt disagreement over fundamentals. Pausing there. We're all committed to the same fundamentals. We don't debate those fundamentals. We're going to accept those as taken for granted and work within them. Men whose research is based on shared paradigms are committed to the same rules and standards for scientific practice. Acquisition of a paradigm and of the more esoteric types of research it permits is a sign of maturity in the development of any given scientific field. Now, what do we then say about this description of normal science as involving already joining a community of people who are like-minded? What about the person who is engaged in observation and looking at the world? And sometimes we think of scientists as having their own eyes, having their own ears, having their own senses, and working through the process on their own. And that the beginnings of normal science is actually someone who goes off and does a lot of collecting of facts and then putting those facts together and testing them by means of experiments and formulating theories. Is that perhaps not the beginning of science? Now, though this sort of fact collecting has been essential to the origin of many significant sciences, and then Kuhn wants to say that's not really scientific, or that's perhaps pre-scientific, and he goes on to put it this way. One somehow hesitates to call the literature that results scientific. So, initial observations, data collection, formulating tables, and so forth, that's not yet scientific. Science only comes later in the process. So we have a suggestion is anything that is too individualistic, anything that is too observational and independent in that way, Kuhn is backing away from including that in science. That's going to be at most pre-scientific. Part of the reason is this emphasis on paradigms and the commitment to the paradigms. No natural history can be interpreted in the absence of at least some implicit body of intertwined theoretical and methodological belief that permits selection, evaluation, and criticism. So we have a suggestion here that the paradigm comes first and perhaps observation occurs within the context of the paradigm. If that body of belief is not already implicit in the collection of facts, this is sometimes the concept of theory ladenness. Even basic observation of fact collecting is already bearing theory or theory laden, as the concept directly puts it. In which case, more than mere facts, right, are at hand. It must be externally supplied, perhaps by a current metaphysic, by another science, or by personal and historical accident. So we're backing away from the notion that there is such a thing as pure observation or objectivity in perceptual awareness, or that there are such things as basic isolated facts that we can come to be aware of, and that science proceeds on the basis of that. In some sense, the theory or the paradigm or just one's personal worldviews as background is already there first, and observation happens within that particular context. The nature of normal science. Once we have arrived in this normal science, right, a reiteration of the theme of paradigms, they gain their status because they are more successful than their competitors in solving a few problems that the group of practitioners has come to recognize as acute. Now, normal science consists in the actualization of that promise, an actualization achieved by extending the knowledge of those facts that the paradigm displays as particularly revealing, by increasing the extent of the match between those facts and the paradigm's predictions, and by the further articulation of the paradigm itself. Strong sentence here. Few people who are not actually practitioners of a mature science realize how much mop-up work of this sort of a paradigm leaves to be done, or quite how fascinating such work can prove in the execution. And these points need to be understood. Mopping up operations are what engage most scientists through most of their careers. And so mopping up is a slight pejorative concept here. It's like we're not bold adventurers seeking new truths and engaging in vigorous debates and so forth. Instead, we're working within a conceptual scheme. Everything has been suggested and predicted, and we're doing confirmations, right? Or we're just doing slight extension, and it's mop-up work in this, and that's mostly what most scientists do most of the time. No part of the aim of normal science is to call forth new sorts of phenomena. We're not really about discovery, about exploration, about adventure, right, and so forth. No part of the aim of normal science is to call forth new sorts of phenomena. It's the wrong conception of what scientists are doing. And indeed, those that will not fit in the box are often not seen at all. So in fact, they're engaged not only in mop-up work, but they are, because they have, so to speak, their professional blinders on, they're just not aware or able to see new things, even if those new things do happen to come along. And not only that are they not able to see, not only do they have the blinders on and see the world only as their paradigm allows them to see, if someone comes along and says, hey, what about this fact over here or this observation over here, they don't like it. They resist that. They become, as Kuhn puts it, intolerant. They are often intolerant of those invented by others. So we need to understand scientists not as revolutionary, not as open-minded, not as on this great quest for the new and the bold and welcoming discussion and debate. Instead, something rather the opposite of that is what Kuhn's version of the history of science will lead to. And then what about science students? The idea that as a young person you're open-minded, you're thinking through all kinds of scientific questions, and you're eager, right, and so forth. That's not the way science education goes. Science students accept theories on the authority of teacher and text, not because of evidence. What alternatives have they, or what competence? So scientists, students do not look at the world for themselves and perhaps with the guidance of the teacher and the text, work through the laboratory experiments, work through the competing hypotheses and process the math and the logic for themselves and independently reach the same conclusion. Instead, it is an top-down authoritative method of kind of indoctrination. That's again a bit strong here, but we're close to that, and that will be confirmed a little later by Kuhn. So we go to school, we learn what the teacher tells us, we memorize and come to believe what the text tells us, we get our certification, then we are allowed into the club, we can become practicing scientists, and then we go on to a career mostly of mop-up work. That is the portrait of science from Thomas Kuhn as historian. Now, like the choice between competing in political institutions, so the idea that somehow scientists are more objective, say, than politicians, that we're also going to set aside. And so we have a direct parallel here. Like the choice between competing political institutions, that between competing paradigms proves to be a choice between incompatible modes of community life. So I'm a young person, I'm coming into political thinking for the first time. I'm aware that there are, say, different political viewpoints out there. How do I choose which one? It's not a matter of assessing the evidence, right, and so forth. It's a matter of committing to a certain community. And both of the communities are, of course, trying to entice me to join their community and not those bad guys over there. Kuhn is arguing the same thing happens in the sciences. Because it has that character, the choice is not and cannot be determined merely by the evaluative procedures characteristic of normal science. That is to say, it's not observation, hypothesis, experiment, math, logic, and so forth. It's something else. Now, we do those things, but we only do them once we've already made this commitment to a particular community with its way of looking at things. And then when we do that, we are just using the tools of our paradigm to justify our paradigm and to criticize any other paradigm. And as Kuhn points out, logically, that's to go to beg the question. Right? When, as paradigms enter, as they must, into a debate about paradigm choice, their role is necessarily circular. Each group uses its own paradigm to argue in that paradigms defense. So we have then competing communities, and they are doing logic, so to speak, but the logic is circular logic, and there's no way to apply the logic outside of that paradigm, because what counts as logical is defined from within inside the context of that paradigm. So if I'm already outside of the paradigms, then what I need to do is just make a kind of commitment to one or the other, but it's not the standard image of what we think scientists are actually doing. Now, what will then happen, of course, is at some point people do change their minds. They do say, all right, this paradigm is not working. I'm going to make a new commitment and go over to this other paradigm here. I am then engaged in a revolution, and if it's not just me, if it's a whole community of people, we are in a revolutionary moment in science. So we go from one paradigm to another paradigm. The historian of science may be tempted to exclaim that when paradigms change, the world itself changes with them. And this is an important point here, because what do we take the world to be? Do we think the world is what it is? And it goes, of course, what it is. And what we do when we change our theories is we change our minds to something that we think is better fitting the way the world is. Kuhn is suggesting that that small o objectivist understanding is also wrong, that what we call the world is a function of or dependent upon the paradigm or the theory that we have adopted. So if we change our theories, the world itself changes, and that's why this is a significant temptation, as Kuhn puts it, just at this moment. But then he reiterates it with a standard example from a perceptual illusion. You can look at this line drawing, a kind of impoverished set of lines, but you can make yourself see it as a rabbit and then change your focus and then see it as a duck. What were ducks in the scientist world before the revolution are rabbits afterwards. Now, are they actually ducks? Are actually rabbits, or is it just that whatever is there and we are looking at it in two different ways? Kuhn is suggesting the more subjective approach. Now, the competition then is over. How did this competition happen? People have changed from duck to rabbit or vice versa. The competition between paradigms is not the sort of battle that can be resolved by proofs. This is not a logical movement that we are engaging in. It's a non-logical, alogical, and perhaps, if we emphasize the arbitrary and the social communitarian elements as well, illogical. We have already seen several reasons why the proponents of competing paradigms must fail to make complete contact with each other's viewpoints. Right? Once I am in this way of looking at the world in this paradigm, I can't understand the other paradigm. I cannot see how they are looking at the world, evaluating the world. And the same thing holds for them. So it's not a matter of who has the better logic or the better proofs. That's not relevant at this moment, Kuhn is saying. In a sense that I am unable to explicate further, the proponents of competing paradigms practice their trades in different world. So it's not a metaphysical universalism, the same world, the same reality, with different interpretations that can be resolved, hopefully, by facts and logic. Rather, they are in different worlds, right? And what the world as it really is by itself, right? Nobody doesn't really know that. We see the world according to our paradigm. We evaluate the world according to the paradigm. And so we are literally in different worlds. Therefore, this language of open-mindedness, of observation, logic, and so forth, and following the facts, that has to go the way how scientists actually work. And notice the use of religious language that Kuhn starts explicitly to evoke here. Equally, it is why, before they can hope to communicate fully, one group or the other must experience the conversion that we have been calling a paradigm shift. Just because it is a transition between incommensurables, the transition between competing paradigms cannot be made a step at a time, forced by logic and neutral experience. Right? It's not logic and objective or neutral experience. It's a kind of conversion, right, that goes on. The transfer of allegiance from paradigm to paradigm is a conversion experience that cannot be forced. It's a kind of subjective commitment that one at some point decides to engage in. And following up on this, suggestion of religious language, Kuhn makes it more explicit here. The man who embraces a new paradigm at an early stage must often do so in defiance of the evidence provided by problem solving. And sometimes we talk about faith as maintaining a commitment despite evidence, despite logical problems that arise. And Kuhn is saying the same thing is characteristic of the social psychology of scientists. He must, that is, have faith that the new paradigm will succeed with the many large problems that confront it, knowing only that the older paradigm has failed with a few. A decision of that kind can only be made on faith. So an implication then of this is going to be that one way of characterizing the relationship between science and religion is that they have very different epistemologies. One is about faith and indoctrination and top-down belief and so forth. And science is about being open-minded and observing the facts and being logical in one's thinking. Kuhn is going to say that is not true. Both science and religion have essentially the same epistemology. Now that we have this new historically grounded understanding of what science practice is, what about those congratulatory labels that science is making progress, that science is about the truth and we're getting closer and closer to the truth as and perhaps even more and more truths or fuller truths as time goes on? What about then this concept of progress through revolutions? And Kuhn asks this question, well, why should the enterprise sketched above move steadily ahead in ways that, say, art, political theory, or philosophy does not? Do we think art has made progress? Do we think that in political theory we've made progress? That philosophers have made progress? And we say, no, typically, no, we're a little more skeptical, and we don't think that's maybe the right concept to use there. But science, yes, science has made lots and lots of progress. But Kuhn wants then to say, well, if you take my analysis of the way science is actually done, it seems like it's going to be much closer to not only religion, but also art, politics, and philosophy. Why is progress a perquisite reserved almost exclusively for the activities we call science? The most usual answers to that question have been denied in the body of this essay. So all of the standard arguments that we will give for saying science has made progress, Kuhn says, no, I have rejected those. We have to set all of those aside. And so we're going to start putting those words in quotation marks as a way of distancing. The phrases scientific progress and even scientific objectivity may come to seem in part redundant. And of course, if progress and objectivity are just redundant phrases, then we just don't use them. We just set them aside and just talk about science, but then we talk about science the way Kuhn has described it, and that doesn't seem to lend itself to any sorts of concepts of objectivity and progress. Other creative fields display progress of the same sort. So there is a kind of progress. The theologian who articulates dogma or the philosopher who refines the Kantian imperatives contributes to progress, if only to that of the category of the group that shares his premises. So we can talk about progress, not that we are being more objective, right, or that we're getting more truths, or that we're getting a better universal understanding of the world as it actually is. Instead, we're going to have a more modest understanding of progress. Progress means once one has committed to a theory or to a paradigm, one working within that refines some things, right? Extends it a little bit, resolves some ambiguities perhaps. That counts as progress, but it's entirely an internalist notion of progress. Throughout the pre-paradigm period, when there's a multiplicity of competing schools, evidence of progress except within schools is very hard to find. So, with respect to normal science, then, part of the answer to the problem of progress lies simply in the eye of the beholder. And to talk about the eye of the beholder is to say that this is on the subject side of the equation, and different subjects have different eyes, looking at different things, liking and disliking different things. So progress then is a subjective notion, and it depends on what your subjective commitments are. It's not that objectively some are better than others. Now, Kuhn then ups the language, earlier making analogies between science and just political theories and political commitments and a lack of objectivity and progress there, religious theories and faith and subjectivities there as well. Science is going to then be in the same category. Inevitably, those remarks will suggest that the member of a mature scientific community is, like the typical character of Orwell's 1984, pausing for a moment, Orwell's 1984, a dystopian novel set in a highly authoritarian regime in which what counts as truth is what one has been indoctrinated into, to the point where the authorities have such power to get people to believe things that are contrary even to their own eyes. It is a thoroughly subjectivized, collectivized, authoritarian epistemology that has been institutionalized in 1984, and Orwell portrays that dystopian world. And so what Kuhn is doing explicitly saying is that's the right model for understanding the scientific community, the politics and the social regime of science. No different. He, that is to say, the member of a mature scientific community, is the victim of a history rewritten by the powers that be. Furthermore, that suggestion is not altogether inappropriate, which is academic speak for saying, I agree with that. The group's members and its individuals, and by virtue of their shared training and experience, must be seen as the sole possessors of the rules of the game and of some equivalent basis for unequivocal judgments. That admission would inevitably raise the question whether truth in the sciences can be one. So perhaps we're setting aside the notions of objectivity and progress, and now what about the concept of truth? Is science even about truth? So we're raising the question about whether truth is another thing that we will need to set aside. And Kuhn goes on to suggest that indeed his analysis, and this is now late in the book, is to say, yes, we should just set aside also the concept of truth. We may, to be more precise, have to relinquish the notion, explicit or implicit, that changes of paradigm carry scientists and those who learn from them closer and closer to the truth. So, relinquish the notion of truth. And then this is at the end of the book. Kuhn then makes an observation. He says, I've given an entire description of science from beginning to mature practice, from change from one theory to another paradigm to one paradigm. That full theory, this is the nature of science, and we'll notice I haven't had to use the concept of truth at all. So maybe we can do science and talk about science without using that concept as well. It is now time to notice that until the very few pages, the term truth had entered into this essay only in a quotation from Francis Bacon. This is, I think, significant. Francis Bacon, we have an episode on him in this Philosophers Explained series, at the foundation of early modern science and early modern philosophy, introducing a very optimistic understanding of the nature of science as based on observation, rigorous experimentation, hypothesis formation, creative thinking, and a willingness to change one's mind as the evidence goes along, and a notion then of objectivity and cumulative truth building. What we find almost 340 years, 3.5 centuries later, is science and the philosophy of science, the history of science, as characterized by Kuhn, has reached the point at which we need to abandon entirely that Baconian understanding of science for a Kuhnian one. Revolutions indeed.